Hey ladies and gentlemen, this is Miss Humbert here, and today we're going to be working with isosceles and equilateral triangles. So that's what our goal is for today, is we're going to learn a little bit more about them and how to use that to our advantage when we're working with triangles. So let's start and take a look at a couple of the theorems that we have to use. So first is the isosceles triangle theorem. If two sides of a triangle are congruent, then the opposite angle, so the angle opposite to those sides, are congruent. So if this side is congruent to this side, then this angle is congruent to this angle. So let's write that out in a statement. If line segment AC is congruent to line segment BC, then angle 1 is congruent to angle 2. Okay, so that's one of the things we're going to be using today. Here's another converse of that theorem. So we're just going to kind of flip it around. So likewise, if angle 1 is congruent to angle 2, so then we look at the sides sitting across from those angles, they are also going to be congruent. So then DE is going to be congruent to FE. Okay, so angle DE is going to be congruent to angle FE. If this would work, that would be great. FE. Okay, so let's take a look. I'm going to go through a proof here. I'm not going to require you guys to do this, but it's something good to kind of get your mindsets up in. So when you're writing out a proof, you have two sides. You have your statement, and then you're going to have your reasoning for that statement. And so that's what we're going to do. We're going to write our statement, and then we're going to write our reason. So we're trying to prove that angle M is congruent to angle P, given that LM, this side right here, is congruent to LP. So basically we're going to prove this theorem right here. So our first statement is that LM is congruent to CP. Or sorry, to LP. LP. If I could read my own handwriting, that'd be fantastic. So LM is congruent to LP. Well, we don't need to worry about that because that was given to us. That was information that was given. Next, I want to prove that LN is congruent to LN. So now I'm talking about this side right here that they share. Well, yeah, that's true because it's reflexive. It's the same thing. Okay. 3, now we want to, the statement is that LN is drawn so N is the midpoint this is not going well for me today, is it? Okay. Is the midpoint of MP. How do we know that? Well, every line has a midpoint. Every line has a midpoint. So now we want to take a look at our next statement. Our next statement is that the line PN, so the line segment PN, is congruent to the line segment NM. Okay, how do we know that? Well, that's the definition of a midpoint. Okay, remember midpoint splits it in half. Okay, that's just by the definition of a midpoint. Next, I can confidently say now that triangle LNP is congruent to triangle LNM. And how do I know that? I know that by side, side, side. That's what we did on the previous note sheet. So, if those triangles are congruent, then we can say angle M is congruent to angle P. And that's just by definition of congruent triangles. Okay, so that's just a little proof. Okay, we're not going to have you guys do that so much in class, but I just kind of wanted to get your brain thinking a little bit. Okay, so let's move on and take a look at using some of these properties. So, we want to find PN, so I want to find the length of this. Okay, well, I know that this angle and this angle are congruent, so their opposite sides have to be equivalent. So if this is 11, then PN also has to be 11 centimeters. So that's all it was, is just figuring out which opposite angles are congruent. Taking a look at number 3, find the value of Z. Okay, so this angle is congruent to this angle. So thus, this angle, or this side, and this side have to be congruent. So then I know that 2Z minus 15 has to be equal to 9. So now I'm going to add 15 to both sides. And I get that 2Z is equal to 24. Then to solve for Z, I'm going to divide both sides by 2. And I get that Z is equal to 12 for that one. So Z is equal to 12. Let's take a look at this one, equilateral triangle. Each angle of an equilateral triangle is 60 degrees. So if it's equilateral, this is 60 degrees, this is 60 degrees, and this is 60 degrees. So if a triangle is equilateral only if it is equiangular. So what does that mean? That means angle A, not angle B. Angle A is congruent to angle B, which is congruent to angle C. Okay, now if that's true, then we also know that line segment AC is congruent to line segment BC is congruent to line segment AB. Okay, those are all properties of an equilateral triangle. So let's take a look at number 4. So for number 4, I know that this is 60 degrees. Here's what I also know. These two sides are equal to each other, which means these two sides also have to be equal to each other. Now we can't just assume that this is a equilateral triangle. So what I'm going to do is I know both of these angles are equal, so I'm going to call them both x. So then I know that 60 plus x needs to add up to 180. So then that's 60 plus 2x is equal to 180. So now we need to solve that for 180. So to solve that for 180, I'm going to go ahead and I'm going to subtract 60 from both sides. So then I get 2x is equal to 120. Then I'm going to divide both sides by 2. And I get that x is equal to 60. So it is an equilateral triangle because both of these angles are 60 degrees. Well, if it's an equilateral triangle, this side also has to be congruent to the other two sides. So that one is 5 centimeters. All right, well, let's take a look at this one. So we know that these two sides are equal to each other. Okay, so what does that tell us? Well, that tells us that this angle and this angle are congruent. Okay, so now we know what, excuse me, what we need to do next is find x. Okay, so because we know that these angles are congruent, this guy is also 4x minus 8. Okay, because they're equivalent, so if this angle is 4x minus 8, then this angle is also 4x minus 8. Well, each of these angles are 4x minus 8. That means that each of those angles have to be 60 degrees because we have an equiangular triangle. All our angles are equal, so they have to be equal to 60 degrees. So I'm going to start by solving this way. So I have 4x is equal to 68. Divide both sides by 4, and I get that x is equal to 17. Again, since all of our angles ended up being the same, that makes it equiangular, so the measure of each angle has to be 60 degrees. So now we know our side lengths also have to be equal, which tells us that this guy right here needs to be equal to this guy right here. Or this guy, sorry. 6y plus 3 needs to be equal to 8y minus 5. So now we need to get our variables on the same side. So I'm going to subtract 6y from both sides. And I'm just going to jump on down here so I have a little bit more space. So then I get 3 is equal to 2y minus 5. So now I need to get that minus 5 over to the other side. So I'm going to add 5 to both sides. And I get 8 is equal to 2y. Divide both sides by 2. And I get that y is equal to 4. So that was just using properties of an equilateral triangle to get to that point. Well, let's take a look at number 6. So for number 6, we want to find x and y. I know that because those two sides are congruent, that these two angles have to be congruent. So thus this angle also has to be 2x. So now all of my angles are 2x. So that means that they have to be a measure of 60 degrees. So 2x is equal to 60. Divide both sides by 2, and I get that x is equal to 30. So down here, x is equal to 30. All right, next, let's take a look at this. Now we know we have an equilateral triangle. So this also has to be equal to that side, because if it's equilateral, all of our sides are equal. So add 5 to both sides, and then I get 4y is equal to 8. Divide both sides by 4, and that's going to give us that x is equal to 2, because 8 divided by 4 is 2. All right. Okay, next, let's take a look at number 7. So for number 7, just to finish this up, I know that this angle and this angle have to be congruent because their opposite sides are congruent. So that means that this angle right here is also 6x plus 8. Okay, now I know that this angle is 80. So here I have an isosceles triangle. Now remember, a triangle has to add up to 180 degrees. So 6x plus 8 plus 6x plus 8 plus 80 needs to add up to 180. Okay, so now we need to go through and add our like terms. So we have 8 plus 8 plus 80. Well, that's going to give us 96. 6x plus 6x is going to give me 12x. So 12x plus 96 is equal to 180. So now I'm going to subtract 96 from both sides, and I get 12x is equal to 180 minus 96, which is 84. Divide both sides by 12 to get my x, and I get that x is equal to 7. So x is equal to 7. Now, to get our y's, I notice that our y's are set on two sides that are equivalent. So 4y minus 2 is equal to 2y plus 2. 4y minus 2 is equal to 2y plus 2. So now we want to get our y's on the same side. So since this is a positive 2y, I'm going to subtract 2y from both sides. So then I get 2y minus 2 is equal to 2. Add 2 to both sides. 2y is equal to 4. Last but not least, to solve for y, I'm going to divide both sides by 2. 4 divided by 2 is 2, so y is equal to 2. So that concludes your note video today. Your homework sheet's actually going to be a review of this stuff and stuff we've been doing previous in the unit. So go ahead and show me your completed note sheet when you're done. Thanks for listening.